isn't it? They'll have the hand mic so that it goes. Does it come through the microphone? Now it comes. Okay, so closer. Says all. Yes, so good morning everyone, if you can now hear me, and good morning in the hall. So we are here at the University of Helsinki in Linus Torvalds Hall, proud of course, and my name is Tuuli Toivonen, and I'm a professor of geoinformatics here at the Department of Geosciences and Geography, and have a super great pleasure to be opening this lecture in a series which is called GeoSPA Talks. It's a new series that we have established with the universities in Finland, researching and teaching geoinformatics. And the SPA, if you wonder, stands for Space, Place and Analysis. So that is the name of the talk series, where we have international and national visitors talking about topical issues related to space, place and analysis. And therefore, like, it's my super great pleasure, of course, to be welcoming Grant McKenzie here today from McGill in Canada. Grant has been or will be visiting us for the whole week here, so he will be acting as the opponent for our PhD researcher Tuomas Väisänen on Friday, and we are looking forward to that discussion as well. But now this talk is to be telling about your work. And if you don't know yet, people online, there's many people online as well, so you can be Googling in the hall. I hope that you don't Google, don't take your computers out, but you can also check Grant's web pages and the lab's web pages. So Grant comes from the McGill University in Canada and is leading a research group, Placial Analysis, which is very relevant to today's talk, of course. He has an extensive career in the field of geosciences and placial analysis, and has been in several different leading universities in the US. Before this position as an associate professor, he was working also in Santa Barbara, California, and in Maryland universities in very topical issues. And today what we are hearing about is place, privacy and mobility, navigating the intersection of location science and human dynamics. A super interesting and topical talk. I hope that you have questions later on. The talk will be recorded so that you know, and it will be available also as a recording later on in our GeoSPA series. We'll have roughly an hour for the talk, depending on how Grant wants to be taking his time. And then we'll have time for discussion and questions. So everyone who's still arriving, so please join us and I'll give the floor to Grant.
Excuse me. Well, thank you very much for having me, and thank you for the kind introduction. I apologize, my voice is there, it's not gone, it's just hiding a little bit today. So yes, I'm coming from McGill University, which is in Quebec in the east side of Canada. If you haven't been there, there's a nice little photo of McGill trying to show its beautifulness. And I lead a group which we call the Placial Analysis Lab, placial being sort of the combination of spatial and place. And I'll talk a little bit more what I mean by place and placial in this talk. Well, so to give a background, I think I didn't click on it. There we go. So perfect. There's, historically in geography, there's been this sort of ongoing discussion about place versus space, place and space as these sort of two components that we think about when we talk about geography in general, regardless of what field of geography that you're in. We can think about space as being sort of the geographic space, or the latitudes and longitudes, the coordinates, the polygons that we think about when we talk about existing somewhere on the surface of the planet, and not even the surface, in 3 dimensions here as well. And historically, there's been a lot of work on place coming from the sort of more social theory or critical theory side of things, with authors like Yi-Fu Tuan and Tim Cresswell talking about place as being this sort of multi-dimensional concept that is space instilled with the meaning of people that visit or inhabit these spaces, right? And so it means that we have these different kind of facets or components that we talk about when we define place. And a lot of the work that we've been doing, and a lot of work that I've been doing in my lab as well, is really sort of trying to understand from a more computational or quantitative perspective, with some success and some not success here too, how we can define places, how we can understand place, and how we can use this in the sort of understanding of sort of relative similarity or differences between places around the world that we see. To give some sort of examples of this is a sort of example that I think of when I think of Washington, D.C. So I spent some time in the University of Maryland and lived in Washington, D.C. And one of the nice things about D.C. is you sort of can go out, run around. There's the National Mall. There's lots of great things to see, and you run sort of past the Capitol building. This is the U.S. Capitol building in the United States, right in Washington, D.C. And as you go past the Capitol building, whatever your opinions of sort of U.S. politics are at the time, you're sort of instilled in you as you go past the Capitol building. And if you're there in the daytime, it's actually can be a pretty busy place, except on the weekends, it's pretty dead. If you go at night, it's actually a very different place, right? So if you go around the Capitol building at night in Washington, D.C., I would not go alone, right? It's a bit of a more dangerous atmosphere, depending on where you go, which side of the Capitol building you're on. And the point here is that depending on the time of day, the spatial location actually changes, right? So you haven't changed your space. Your space still exists how it is, but the time of day has changed. And so your experience, your sense of place, your understanding of that environment has changed, right? How you feel about that space, all the things you're thinking about, the sights, the sounds, the smells, has substantially changed, even though the exact geographic coordinates haven't changed. And then we can actually take it from a sort of step further, right? And so this was January 6th insurrection that happened in the United States, and this instills a whole other set of meaning, right? A whole other sort of sense of feelings depending on where you sat in this environment, whether you were watching this or you were there. You have a very different experience for the Capitol building. Again, the geography hasn't changed, right? The geospatial information, the latitude and longitude, the polygon, the boundaries, even the sort of structure hasn't changed. But your interaction with that, your sense of place, your understanding of that place has substantially changed. So I like to think of place as being the sort of the multifaceted, multidimensional, complex structure of which one part of that is space. Right? Well, technically 3 parts, right? If you think of 3 dimensions of place, you have additional dimensions of place that we can use to sort of understand spaces and understand the places that we're inhabiting and the places that we go, the places we visit, where we travel to. Now, place can be incredibly complex to sort of wrap your head around with that with. And when we think about sort of the historical work that has happened in place, it's been phenomenal from sort of describing places in terms of these senses, these emotions. But it's very hard to quantify a lot of that because place means different things to different people, right? And so that becomes very difficult to understand, and then build models to represent places can be quite difficult to do. So for better or for worse, right, we're living in this sort of post-Web 2.0-ish world where we're all sort of glued to our phones or devices in whatever sense it might be. And it's not just your devices here, it's the Internet of Things, right? So this is being recorded. There's sensors in this hall that are detecting the temperature. All those different things we can think about that are actually being used to sort of sense the environment and record everything that's happening around us. And as researchers, we can actually make use of this data, right? So we often talk about digital footprints, geographic footprints. I like the term digital exhaust, right? Which is where our physical lives meet our digital lives, right? The physical world interacts with our digital lives as I pull up my phone and I walk around, collecting piles of information about what I'm doing, not just online, but what I'm doing in actual physical space here as well. And the 2 sorts of sides of this that we talk about are the passive sensing and the active sensing, right? So on your phone, you have, 8, 10, 12 different sensors that exist on your mobile device right now. Barometric altimeter, temperature, GPS, all the different things you can think of. And that is collecting information along with sort of cell towers other kind of information, are collecting where you're going and what you're doing at all times, or depending on what you have enabled on your device. And then we have the flip side of that, which is our active data collection, right? Which is where we're actually actively contributing data to the data sphere out there, right? The quintessential example we use of that is volunteer geographic information or user-generated content through social media, right? So we're choosing to share the kind of information like our Instagram posts, our TikToks, or Snapchats, whatever that might be. I go for a run in the morning and I upload my heart rate to Strava, for instance, right? So all of this data is stuff that we're actively choosing to contribute. So we kind of have these two sides of the coin to actually understand sort of the data, the environment that we're actually working with. And as researchers, that typically offers us an incredible amount of information and a lot of promise to actually explore some of these data. But what's important to understand here is that these are all just sort of proxies for the real world, right? We're kind of sort of in this plateau world where we're not seeing the actual world, we're seeing the data, and we're visualizing, we're understanding the world through these data sets that we have. And so we did some sort of early work exploring the differences that we see in the different types of data that we collect. And one of the things that I'm quite interested in, and my group is quite interested in, is this sort of temporal dimension. You'll see this throughout the talk that I talk about time as being a important, if not more important than space in some ways, dimension of understanding place. And what we did was we looked at passive data collection from Google. So Google collects your data, that shouldn't be a shock to anybody, but as you're walking around the environment, and if you have location services turned on, if you have Google Maps installed in your phone, you've all read the terms of use, right? And clicked that button that said, I agree, and I'm happy to share my data with Google. And that's where Google gets their traffic information. That's where they get a whole bunch of other information. But one of the things you can go to is you go on Google Maps and you look at like a store, like a coffee shop or whatever, and it'll tell you the popular times, what time of day a place is popular. And that's all driven by us walking into a shop, Google doing some heuristics to figure out where you are, and then reporting back the sort of popularity based on the number of people, the foot traffic for those places. The flip side of that is we also have an application called Foursquare, and sort of the gamified version, which is called Swarm. It's like a geosocial media game kind of system where people check in. This is the active data collection. They're choosing to check into a place on social media. And they're checking in with their friends, or they're competing with their friends to become the mayor or whatever they call it, to sort of have some saliency to where they're going and what they're doing. And what was interesting to us is that both of these represent the temporal dimension of the places people go to, right? So this is an example of hardware stores, a category of hardware stores. This is data that's taken from the East Coast of the United States. We had about 200,000 points of interest. We narrowed it down in this example right here to star hardware stores, but we have about 800 different categories of places. And what you can start to see here, which is kind of interesting, is that for Google, the passive data collection, people go into hardware stores. If this is Monday down to Saturday and Sunday, this really reflects the tradespeople, right? People that are actually showing up at hardware stores in the morning, getting their lumber, getting their tools, whatever they would need to, going off to work, right? Saturday and Sunday are far less in that example. And hardware stores from a Foursquare perspective on Saturday and Sunday, this sort of represents that weekend warrior, right? The person that goes and fixes their deck or builds a sauna in their backyard, right? So this is that kind of person that's actually, choosing to share that because they want their friends to know what they're doing and where they're going, not necessarily caring so much about the sort of day-to-day activities that we have. So the important distinction here is, depending on which of these data sets you use to understand human behavior, understand place, you're going to get very different understandings of what place is, right? So it's an approach that requires us to think hard about what do we want to represent and how do we want to use these systems to understand the world around us. Some of this work sort of aligns with a bunch of the work that I did as part of my PhD, which I'll just very briefly talk about, which was using points of interest here and the temporal aspects of points of interest to understand the pulse of a city. So these are just points of interest, 200,000 of them in Los Angeles, where we looked at the times of day that people visited certain places, and then sort of looked at the pulse, by the temporal pulse, throughout the day, what types of places are most popular at what times of day, and you can sort of see hot spots in the city light up depending on when people are more likely to go to them. So this was an attempt at sort of building into like an urban planning or an urban development system, some way of understanding temporal dynamics. So let's talk a little bit about where I'm going with the talk. This is kind of the introduction for what I wanted to talk about today. And the sort of sales pitch for this talk was I wanted to give an overview of what we do in the Palatial Analysis Lab, sort of touch on a few different topics that I think would be relevant to the group here as well. So I'm going to talk about this sort of through these three different facets. I'm going to talk about place more generally and more specifically talk about regional variations of place. I'll talk about mobility patterns, new mobility, micromobility, which is one of the sort of pillars that we do in our lab, the research that my students do. And then privacy, which has been a topic of mine for a while now, sort of a passion project that has developed into a lot more of having a bit more of a leading role in the kind of research that we do. So let's go through those, and again, if you have any questions, feel free to let me know at the end, and I'm happy to address these. So let's talk about placial variability to start. Excuse me. So if we think about place, back to the sort of definition, at least I was talking about, and we have different understandings of what place might be, the activities that we do or where we choose to go are pretty habitual. Meaning we think of ourselves as being kind of unique individuals where we do certain activities, and I go to a coffee shop here, and I go to a restaurant or whatever the case might be. But the reality is, as human beings, we're incredibly habitual, right? We do very sort of common things at the same time of the day. There's not a lot of variety to what we actually do in terms of the temporal distribution. We go to restaurants in the afternoon, and in the evening we go to coffee shops in the morning. These kind of activities are fairly predictable for what we actually want to do. So what was interesting to us is to say, not just the times of day that we do things, but the amount of time that we stay at a place. So how long do I go to a coffee shop for? How long do I go to a restaurant for on average? If I look at these across cities, is there similarities between how people in cities interact with their places? Do people spend the same amount of time at a drugstore in a place like Houston than they do in a place like Chicago? So we're really here focused on the four most populous cities in the United States, but our ongoing work is sort of expanding this outside of the area. It's just we have a lot of data in the United States to study this. And say, are there regional differences between how people interact with these places depending on where they are? And to address this, we still look at the sort of location services data that we have collected. Your cell phone's turned on, you can see where you're going, and we can look at those popular times from Google, right? So back to that example, this is what I talk about. If you go on Google Maps on your phone or on your desk or on your computer, you can see that it has popular times. But you also see that it has, I tried to find an example from Helsinki, but I think Google finally actually removed this. So we have this data, but they've actually gotten rid of this now from their platform. People typically spend 15 minutes here, right? So this is, I think, Starbucks in New York City, and 15 minutes is based on people coming and going from that place, how long they estimate or they have figured out people typically spend at this. Now, this number ranges, so sometimes they say 30 to 45 minutes, sometimes they say an hour to an hour and a half, depending on what place you're actually looking at. It also depends on the data, right? So they don't have this information for all places because you need to have a lot of people, a lot of foot traffic go to a place in order to report this. So we have a sort of subset of our data actually reports this. And what we did was we actually aggregated this by the category of place, the type of place that we have. And so if you look at all the tags that Google has for places, and these are contributed by the business owners, we have probably about 1,000 different categories of places that people can choose to tag their data with. So where they're choosing to go, and basically what the owner thinks is important label for that place. It's kind of curated by Google. It's kind of a gray area. This is one of these things that's sort of hidden behind the black box in the Google world of how they come up with these categories. But we do have a definitive list of all the categories that places were tagged with. So then our question is, well, let's look at the distribution of these. So if we aggregate them to the category level, so bars, restaurants, parks, can we look at these and say, how do they vary between different cities? So if we look at a category like family restaurant, we can see how that temporal, these are density plots, and these are minutes on the x-axis, how they vary depending on the different categories of places that we have. So in New York City, Los Angeles, Chicago, and Houston, and these different colors. And you can see that there is some variability right? So these are statistically significant in terms of their difference in how something like family restaurant varies between regions. Something like wine bar is a little bit more similar. There tends to be a peak at around an hour and a half in terms of the visitation behavior of what people show, regardless of where they are. And then you have an example of something that's atemporal, right? Regional. It doesn't actually shift depending on where you are. Something like fuel stations, right? You go to a gas station, it's not going to change depending on what city you are in. People go to fuel stations for the minimum amount of time to get fuel and then move on. This kind of information is actually quite important if we think about if you're a company or a researcher that wants to understand dynamics. Having to actually index all of these different temporal patterns for all the cities in the world can be pretty sort of data storage and computationally intensive. So if you can figure out that for about half the categories, there's no difference between regions, you can just pick those up and move them to a different city. There's no need to reassess that for every single city that you're doing the study on. What we found is about half of the categories are regionally variant, and half of the categories are not. Drugstores, fuel stations, liquor stores in a lot of cases, like people don't really change their behavior, at least in the United States in the study that we're looking at here. So then our next question was to say, okay, well, January 2020 was an interesting time, right? That was right before the onset of the pandemic in the United States. So we have some data from before the pandemic and the visitation patterns of what people actually showed us. And then we have data from a year into the pandemic. And this is when we actually started digging into the data in a lot more detail, is to say, well, how did this change, these regional patterns change a year later, right? And so what we actually start to see is that family restaurant previously, this is 0 to 120 minutes or so, suddenly shrunk down to sort of a median of 15 to 30 minutes for family restaurants, right? And this reflects the reality that in the United States and a lot of the world, family restaurants suddenly became takeout businesses, right? Or in a lot of cases, delivery businesses, but I'll talk about that in a second too. Cocktail bars, we see a kind of a different pattern here, some regional variability to this one. And notably, I'll bring this out here, and I'll talk about this in a little bit as well, is Houston, which is in Texas, which is politically a very conservative state in the United States, didn't change much, right, between before the pandemic to during the pandemic. And this really reflects the sort of policies and regulations that came out by the state government, sort of mandating that some shops close or shorten their hours or whatever the case might be, or just the reaction of individuals. We have some correlation data, but I don't want to speak too much to the causation of it, other than to bring that to people's attention, which I thought was sort of an interesting area for future research, I guess we should say. Something like liquor stores, again, didn't really change much depending on what we saw before. So liquor stores still existed in the data. People still went to them, but that didn't really change the visitation pattern. People aren't spending hours in a liquor store usually. So this is just showing, I've got a lot of graphics here, but comparing 2020 to 2021, for our columns here are different cities, and our rows are 3 different categories of places. So we can look at bars in New York City, Los Angeles, Chicago, and Houston. You'll notice for the first 3 cities here, they changed substantially, right? So from 2020 to 2021, they shortened in their average time people visited these places. And then we look at, for Houston, less of a change that we started to see. Things like coffee shops, again, shifted in some cases, less so in others when we get to Houston. And then something like a bank really didn't change a whole lot, right? People, again, are not... A bank is something people had to interact with, I think, in a lot of cases, and their visitation pattern is not like people enjoy hanging out at the bank. Most people, I guess, some people do. So those patterns didn't shift a lot in terms of how we understood this. What we were also interested in seeing was, well, what happened to our place types, right? So we have these thousands of categories of places, and since these are controlled by the users or business owners, what happens to these categories sort of before the pandemic and then into the pandemic in terms of the tags that people chose to use? So they could go in and change your tags for a business, the categories of place that you define yourself as. And not surprisingly, for like a place like New York City, the number of restaurants that switched from restaurants to delivery restaurants went up 520%, right? So it's not super surprising, and in most cases, this was pretty high across the board of the number of places that shifted that way. And then we saw mailing services. Actually, liquor stores went up, so a lot of places changed their categories to be liquor stores. You can read into that what you'd like. Electronic parts store, which was interesting, wine store, supermarkets, mailbox rentals, these sorts of things. And then the other side, we saw a decrease in things like gyms. Now, this also reflects the fact that a number of these places closed during the pandemic, right? So we have the same place before and the same place during the pandemic. So we matched these two, and then we saw that a subset of those actually just disappeared from the data. There's a number of reasons for that. I mean, the pandemic being one of those, but just businesses close and businesses open over the course of the year. So we didn't really know. We had these two snapshots. It's difficult to exactly say what the reasoning was. But in looking at this thing, things like gyms, nail salons, beauty salons, hair salons closing is kind of indicative of what we did see in terms of the service industry being affected by COVID or the pandemic in this case. Then our sort of question from this perspective was more of a discussion about equity, right, or sort of the socioeconomic aspects of place visitation patterns. And we looked at the different cities that we had here and said, if we compare 2020 to 2021, what happened to the amount of time that people spent at places in general? So this is all points of interest, and then we have our categories of restaurants, coffee shops, and fuel stations, just for example. And then we wanted to see, depending on low income, which is on the left here, and then on the right is our high income, how much time changed? What was the decrease in time that people spent at different places? And what you can see for something like restaurant here is that for low income communities, the amount of time someone spent at a place decreased less than for higher income communities. And this was pretty true, or this was true for pretty much all of the different categories we saw, other than fuel stations, which really didn't change much at all. And for overall our POI here as well. And part of the reasons or the explanation that we developed, and this is work with my colleague Kevin Moenda, who's at Brown University, was basically what I think a lot of other researchers found here as well, which is that people in lower income communities couldn't afford basically to shift their patterns, right? So where they were working, shops they had to keep open to keep businesses going. People that were in higher income communities could afford to change their patterns, right? Could stay home, could shift the dynamics of how they actually moved in the city, where people from lower income communities arguably didn't have that same ability to do that. And so we sort of see this shift, depending on, this is New York City, sort of a lower income community versus a higher income community, how those patterns changed, right? We saw shops were able to shut down and close in higher income communities, and they didn't have that ability in lower income communities because they needed to stay open because the people needed the money more than maybe somebody living in an upper middle class community in this case. So there's a lot of ongoing work that we're sort of exploring in this sort of more than just in the United States, sort of expand this to Canada and through Europe as well, and sort of longitudinally see how this has changed, right? So as we think about sort of coming out of the pandemic, according to the WHO, what does that do? Have we seen a rebound in the visitation patterns, or what does those the points of interest temporal patterns start to look like? This led to some work that we've done. I spent some time at Tableau Research in Seattle, which is, I guess Tableau is now owned by Salesforce, where we were really looking at coming up with models for similarity based on places and based on the inhabitants of places. And so we built this platform called MixMap, and we're sort of embedding some of the work that came from the stuff we did in the past into developing what essentially is a similarity model. So this is Los Angeles, and we're taking a number of different socioeconomic and demographic factors here as distributions. So we don't have a single value, but we have a distribution or binned values for things like race, income, education, and allowing users to basically say, I want to find places similar to X. So you pick a census tract or a neighborhood or a boundary, adjust the parameters that are of value or importance to you, and then find the most similar place elsewhere, in this case in California, that shows a similar pattern. There's a bunch of sort of visual analytics tools you can share and save and view other patterns based on sort of different data sets that you can contribute and upload yourself. But the main goal for this was to basically, one of the projects that is happening at Tableau is there's a group called the Racial Data Equity Hub, which is really quite interested in understanding sort of how different communities are affected by different policies and how we can use visual and data analytics to sort of explain or understand the impacts of these policies. And so if we can pick a certain region or extract data from a certain area and find other similar areas that maybe had different policy implementations that might help us in understanding what the next steps might be in certain regions that we're looking at. Okay. It's always interesting to see if Google will let me. Oh, this wants to restart. There we go. Okay. So that was really the sort of talk about a sort of introduction to what we talk about when we talk about place and the temporal dynamics and the sort of regional variability of places, which has continued to be an interest in my group, in my lab as well. The other side of this, which I think is a big part of understanding place, is how people get between places, right? It's understanding the places that people go to is one thing, but to really understand the full dynamics of a city or any kind of geographic region, it's important to understand the sort of dimension of movement or mobility, how people get between the places that they're going, between the activities or the affordances of activities that they're going to be doing. And so to do this, we talk about human scale mobility, and some of the work that kind of fell into, and a lot of the students in my group have really adopted and done a lot of really cool work in I'm kind of biased, but in my opinion, to explore some of this stuff. So you might remember a company, OFO. You'll remember, I think OFO is still in operation in certain parts of the world. This was the early examples of their pedal non-electric bike share systems. When I was living in DC, these were like in 2017, 2018, these were kind of dumped on the streets of Washington, DC, and we saw sort of massive adoption of these. For the most part, the cities really didn't know what to do with them. And very quickly, they became sort of obsolete as we saw electric vehicles start to take over in these worlds, right? So then you started to see these sort of mass grave sites of these bike share systems from China, where you have these sort of just dumps of these non-electric vehicles sort of in sort of dump or yards or places where people would actually just sort of leave these, and because of the rise of sort of e-vehicles or electric scooters and electric bikes, right? And so this was sort of the onset of e-scooters. They kind of took over. Just walking around Helsinki, I see that it's still quite prevalent here as well. In Canada, we've had a really strong pushback, similar to I think what they've done in Paris recently, so sort of pushing a lot of scooter companies out. And a lot of that's driven by the fact that there was some horror stories that came out of the United States early on, right? So we called it the scooter apocalypse. Everybody was terrified about these scooters and what was going to happen. And it's like anytime you introduce any new technology or any new transportation into a very complex and very busy transportation ecosystem, you start to have this kind of reaction. And what we see in the US and in most of Europe as well is people have come to terms with it for the most part. There's better models for where you can actually park these things and leave them. People are more accustomed to seeing these scooters, and they're less likely to be sort of kicked over and knocked over and put in paths. So that still does exist in a lot of cases. Now, what's been interesting to us is to say, like this was some of my early work looking at this, was to say, well, how do these e-scooters, these dockless or free-floating, if you prefer the positive side of the term, how do they compare to more traditional municipally funded, government-funded bike share systems that a lot of major cities have? And these docking station-based ones, and this is Capital Bike Share in Washington, D.C., have a series of docking stations placed throughout the city that have been optimized to ideally meet the needs of the population. And we have these e-scooters, which are not organized by the city. They tend to be private companies that come in and leave their scooters and try to optimize where they place them as well. And this was sort of very early work to sort of understand the different spatial and temporal dynamics of where these systems were being used. In 2018, when I did this study, it was really clear that the docking station-based vehicles were being used for commuting behavior, right? That was the main use. If you were a member, you could see the sort of standard peaks that you would expect to find sort of Monday through Friday, during rush hour, and sort of generic sort of rounded peaks in the weekends. And then casual, these are the kind of tourists or people that use them occasionally, didn't exhibit that same behavior. And then on Monday through Friday for e-scooters, a little bit of morning peak behavior, but for the most part, they were just being used for pleasure or recreational-based activities, and that was reflected in the spatial patterns that we saw for them as well. Now, this was very early on, right? This was when scooters first came out, and understandably, a lot of people didn't want to rely on them for a mode of transportation to get to and from work. A lot of people were taking these trips just sort of to experience going on scooters. And part of our work right now is actually redoing this study now to see how this has actually shifted or changed in a city like Washington, D.C. and other places. We also explored the differences in the types or the operators, the different vehicles that we have. So in Washington, D.C., there's a number of different operators that we have access to, including Jump, which is the electric bikes. Again, this was back in 2018, and we can then look at the spatial patterns to see where they're operating, where the different patterns happening. And what you can start to see here is that depending on the size of the fleet, they actually exhibit very different behavior. So Skip, which is blue there, has a much larger fleet of vehicles. This was at this time. They're now all restricted to 400 vehicles. And you could see they were very sort of highly densely located sort of in the center of DC. But if you normalized it sort of by the trip volume that we have, we see that a company like Lime actually dominates the whole region. So even though they don't have as many scooters, they're more widely distributed across the region in terms of how they're being used. It's interesting, there's been some recent work looking at this and comparing how e-scooter operators move into cities, and it tends to mirror like a cartel model, if you're familiar with that, like the sort of combativeness of like one scooter company taking over another's domain and then them moving out into another domain and so on. So there's some really interesting sort of work that has analyzed these different patterns. Then we were really interested in saying, well, how does this compare to ride-hailing, right? So if we take scooters as being a sort of new mode of transportation, the micro-mobility, sort of short-term scooter rentals, compare them to another sort of arguably new mode, but probably more well-established, like Uber or Lyft. Uber movement data, which was a phenomenal tool, allowed us to understand sort of between different traffic analysis zones, how people actually moved within the city and how long it took depending on the time of day and day of the week. So we did this analysis to basically say, how does that compare to e-scooter movement, the data that we have? And then it turns out in a lot of DC, it's actually much faster to take a scooter, not super surprising. And as you might expect, it's really during the rush hour time periods that scooters are much better, right? So DC is a very congested city, it's therefore not surprising that if you're going longer distances, it makes sense to take an Uber. If you're traveling short distances and you're traveling during rush hour, it's much better or easier to take a scooter. I understand these are very different modes of transportation. You're going to have different needs while you do that, but we were just really interested in seeing what those differences might be. So sort of continuing on from that, some of the work that my student Daniel has been doing is to say, well, if we're really interested in mobility as a function for understanding places, can we look at mobility as a similarity measure? Right? What I mean by similarity is when I go to a new city, like when I go to Helsinki, it's very hard for me to understand the neighborhoods in a city abstractly, right? You can't really come up to me and define a certain neighborhood of Helsinki without using relative terms, right? It's a lot easier for you to say, oh, this is like this, right? If I know parts of Montreal, and maybe you know parts of Montreal, you could come to me and say, oh, this part of Helsinki is like the Plateau or is like downtown. That relative aspect, that similarity that we often use in just our everyday language, I think is essential to understanding places, because places by their nature are hard to define abstractly, right? It's that similarity, that sense of place that we often use to define places. So our question was, can we use these mobility patterns as a measure for finding similarity between cities? And what we did in this case was we looked at all the e-scooter data that we had for a whole bunch of cities, and our example here was Stockholm and Berlin. And we said, maybe I'll just stop this for a second. What we said was, if we look at like the origins and destinations of all our scooters, we have trip time, we have time of day, we have the distance that people traveled. Can we use all these different measures or attributes of trips to construct like a vector or distribution for trips and use that for building a similarity model? And so each of these hexagons, and this can be neighborhoods as well, hexagons was arguably just easier for us from a static perspective, and calculate, the number of trips that originated in that hexagon the total number of cells that were destinations, like unique cells outside of that hexagon, the distance that people traveled outside of that hexagon, and then that like the time of day, how popular was that hexagon in the morning, in the afternoon for trips originating or completing in these different regions. And then this is sort of just a visualization of the platform where we can select a hexagon in one city and then run a similarity measure. In this case, we use Jensen-Shannon divergence to calculate the similarity to all the hexagons in a different city based on these mobility attributes of that specific hexagon. And because we're not experts in understanding, or we don't know what people care so much about in terms of the mobility patterns, what is important to you, we offered a sort of a tool up here to allow you to change those weights depending on what matters to you. So it might be time of day that is the thing that matters most to you for understanding similarity between regions, or it might be the number of unique trips that leave from that specific cell. And that again will adjust the weighting and the similarity that we find for these. So part of this goal was to then basically say, let's say for example, I want to go to a new city. I know my city, I like the mobility patterns, I like the access to mobility that I have in my part of the city. Can I find a similar part in another city? Or realistically, if I'm a transportation or urban planner in one city, can I look at another city and see what they've done to make the sort of patterns or encourage the sort of transportation modes that they have happening in that city and see how that compares to certain other factors like socioeconomics or demographics? And this aligns with the work that my student Don is doing, looking at what we call mobility vitality, which is sort of like a subset of urban vitality or urban vibrancy, to understand, what are the different modes of transportation. She's expanded this outside of e-scooters or e-mobility to look at bike share, to look at taxis, to look at Uber, to look at subway and bus ridership, to look at a city like New York and say, well, what do these different patterns or combinations of different patterns do for understanding the dynamics of a city? What are the similar regions of the city and what are the diagnostically different regions of the city? So how are we seeing some variability happen in this? And my student Priyanka is looking at this from an equity perspective, right? So if we compare cities, in this case we have DC, Seattle, and I think Atlanta here, can we use some spatial regression approaches to understand the different mobility patterns of different groups, right? So just socioeconomic and demographic groups. And her sort of the approach to this is basically saying, we're taking a similarity-based approach to say, do similar groups in similar cities use e-scooters and e-bikes in the same way, or are they very different in terms of the behaviors or patterns that we see in terms of usage? And some of the work that I'm looking at right now, or the ongoing work that I'm in the middle of developing and hopefully will be releasing fairly soon, and I hope will be of interest to this group here as well, is to take the data that we have for things like e-scooters, and I have about 3 years or 4 years worth of e-scooter data from a city like Helsinki. We have 2.5 million trips, and again, compute those distance measures, right? And so look at the duration, how long it takes to go from one part of a city to another part of the city. Look at the times of day people take those trips, and look at the average sort of binned duration in sort of 5-minute intervals. How long do people take to do these specific trips? Looking at in a neighborhood perspective, but also looking at it in a hexagon, depending on what resolution you're interested in, and then compare this to other cities, right? So we have data for about 50 different cities, about 2 to 3 years of data depending on the city, and then we can compare it to like a city like London and see what those mobility patterns look like. And I was actually sort of motivated to do this, and you can download the data for all of these cities as well. Looking at some of the mobility access work that actually has been done here and published, the data sets that have been published, it'll allow you to look at how people or the population changes throughout the city. And one of the things I think would be really interesting, and from a collaborative perspective, is to compare the sort of e-scooter, e-bike mobility patterns with other methods of transportation that we've seen in like a city like other cities around the world. Don't start it again. There we go. And the last thing I wanted to talk about is location privacy here. So location privacy, because so much of what we do in our lab or in our group is sorts of fits in this sort of big data, I call it placial data, but you can think about sort of multi-dimensional attribute data. And a lot of this is coming from online social content, right? User-generated geosocial content that's been contributed. The obvious discussion or argument that always ends up happening out of this is what about the bias and the privacy of these data, right? So bias is one thing we can talk about here, but the privacy of the individual data and what they're choosing to share is another component of this. And so sort of inevitably, this leads to a whole different area of research, which is how do we deal with the privacy of the kind of data that we just deal with on an everyday basis, like the kind of data that we collect online or have access to via tweets, check-ins, or whatever kind of information we have. And from a sort of research or educational perspective, how can we preserve the privacy of individuals in doing this data? I've kind of shifted this around a bit today because I wanted to talk a little bit about some methods in using some of the social media data just to demonstrate some of the problems we face as a discipline, and maybe sort of more in how we think about traditional privacy, but viewed through a geographic lens. So let's think about it that way. One of the things to sort of start this component of the talk is to think about the data sets that are out there. A good example is this New York taxi cab data set. And so this is taxi cab data set, I think it started in 2008. All taxi travel that happened in New York City originally had latitude and longitude coordinates where someone got into a taxi and someone got dropped off. Has a timestamp to the second about when they got picked up and dropped off, has how they paid, how much they tipped. A really, really rich data set that you could actually have access to and is still available online, though they've now sort of aggregated it to city block level because of some of the issues they found with this data. So the problem with any kind of data set that you release pseudo-anonymized, right? They had vehicle identifiers for the taxis, either the taxi license plate or the VIN, the vehicle identification number, is that you never know what additional data sets exist out there, right? We call these linkage attacks, the ability to get an additional data set which you can use to de-anonymize a seemingly anonymized data set. And what was not considered, and this was actually a graduate student from Northeastern University that did this, looked at sort of paparazzi photos and photos that were taken and published in tabloids that had celebrities getting into taxi cabs, and then looked through the data set, found the taxi cab, and was able to identify where they went, right? So their origin and destination. And they found in a lot of cases like how much they tipped, like whether they used credit card, if it was a MasterCard or a Visa. They were able to figure out their home location for some people as well. So pretty sort of exposing information purely by using other publicly available data to analyze this. This isn't new, right? This has kind of been, these kind of linkage attacks have been happening forever. There was the example of Netflix years ago had a challenge to identify or to improve their algorithm, and they gave you a sample of movies that people liked without telling you the person, and people went in and were able to identify the individuals in the data set purely by looking at movies that had similar IMDb ratings from individuals that were listed in that data set. So again, while the intention is there to anonymize the data, it kind of falls short when we know that there are additional data sets that we can use to de-anonymize the data. So one of the techniques that's been sort of approached historically to handle a lot of this is a method called k-anonymity. So it's a privacy protection method, I should say. And the idea is that you should not be able to distinguish yourself from k other entities, people, records in a database, whatever it is. So instead of reporting an individual in a data set, you report a set of individuals that exhibit similar properties, and you will change the data set such that all of those individuals exhibit the same properties, right? So you might take, if this is a database, a health database, you have a set of people with some diagnostic or diagnosis, you're going to change their name, these sorts of things, but you're going to adjust their age to be at a range. So if you're changing their age to be at a range, you seemingly are now not able to identify one specific person in that data set because no single person exhibits a unique record. They all have some variation of that. Now, there's been additional methods that have come out since k-anonymity. Things like differential privacy are a very sort of focal discussion right now. That's what Google's been using and Microsoft for some of their traffic analysis. Differential privacy doesn't really report on the level of groups or individuals. Differential privacy is fantastic at reporting trends or statistics across a data set. Anonymity is still used quite widely today, for better or for worse, for anonymizing a lot of health records and these sorts of things. We also have this happen in geography. So there's a method called spatial anonymity, where you have a set of points, and you can report a set of points that rather than an individual point, with the idea being that sort of the area of the points is still useful to somebody without having to know the exact location of the individual. Now, most of this work has been approached from a very geometric perspective, right? Just considering points as being points on a map, without any sort of contextual information. But as geographers, we know that they all have contextual information, right? In a lot of cases, these points are points of interest, right? Places or businesses that people would go to. And so increasingly, we have access to information about these, right? So the last part of my talk has all been about what kind of information or what kind of data we have access to about these places. So if you have a specific point of interest here, and we know that it's a charity, or we know that it's an imported food store, there's a whole bunch of other contextual information we also have access to, right? And we can use that data to de-anonymize what is seemingly an anonymized data set in some way. So if I'm an individual checking in through social media or sharing with my friends or posting a photo on Instagram or TikTok at a certain location, I want to anonymize that using a k-anonymity approach. There's a lot that I need to consider here about other data that we have access to, right? So we have things like our institutional constraints, our hours of the day that a place is open. We have the popularity of the place, right? If you look on Google or you look on any kind of social media application that includes locations, it'll tell you a star ranking, how popular a place is or how much it's liked. We also have these temporal patterns that we've talked about before, right? How popular a place is throughout the times of the day. And we have additional data. Like you can constantly think of all the different sources of information you could use to sort of shift what you know about a specific place at a specific time of day as well. So our question here was, does the ability to identify an individual's location within a set of locations, so I'm an individual reporting a set, seemingly anonymizing my point compared to a bunch of others, if we know the time the individual visited the location? Well, yes, we do. We can. So if we have a certain time of day, like Friday at 7 p.m., we have our points of interest. How do we, or can we, in that case, reduce sort of randomly guessing where that person is and sort of do an educated or an informed estimate or guess based on additional variables that we have? So if that's our sort of base data set we're working from, let's sort of take a step back and look at how we would actually approach this from a research perspective. Like, how do we test this theory? Well, we do have all these data, right? We have our Foursquare check-ins, which are our active check-ins. We have our Google place-based check-ins, which are our passive data collection. We have their hours of operation when somebody chooses to go to a place based on when it's open. And then we have our popularity, right? So this is atemporal. This is not something that depends on time. It's just whether a place is popular or not, right? Trendy nightclubs are much more popular than doctors' offices, these kind of things. And then we have all of our points, our categories, right? So this isn't individual points of interest. This isn't instances. These are actually categories of places that we go to. And we have, depending on the time of day, some probability of you being at that place, right? So if we have Friday at 7 p.m., for Foursquare, there's some likelihood you're there. Google, same. Hours of operation, popularity of the place in general, regardless of time. We have information about that place at all times of day, days of the week, months, years. So if that's the basis for what we're dealing with, how do we actually validate an approach that will test this, right? How do we know that this approach that we're this theory that we're coming up with, that time actually matters, actually does matter, right? Well, we can go back and come up with a sort of validation test data set by looking at where people actually check in online. So back when Twitter used to be Twitter and was an API that you could use, you can actually look at the source tag information for Twitter, and one of the sources that's provided is Foursquare, or Swarm in this case, which is part of Foursquare, and people would choose to check into places, and they'd share that on Twitter. So they'd say, I'm at Star Bistro, or whatever that is. I could sort of follow the breadcrumbs through the APIs to get the actual information from Foursquare to figure out what the category of the place was, what the latitude and longitude of the place was, and what time that the person actually visited that place. And from there, I can go back and get the 50 or 30, in this case, closest places to that one place that somebody visited. So now I got my testing data set, right? I have the place that I know somebody went to, and then I have all the surrounding places that they could have potentially gone to. And my job now is to see how accurate I can get at predicting the place that they actually went to. So in total, this was 17 million tweets that we got down to about 55 or 54,000 swarm check-ins, of which we had 22,000 unique points of interest, and we decided to only take one check-in per point of interest. And then we limited it to the 29 nearest POI, so we had 30 points of interest for each check-in, which gave us about 19,500 check-ins. Again, this was our validation data set to see how well our model was actually running. And so if you just take an approach that doesn't include time, your chances of correctly identifying somebody's check-in in that set of 30 points is 1 in 30, right? That's your random. But if we know something about time, what is your chance of identifying that person, right? So if we then take all of our points of interest and rank them based on the probability of an individual being there at that time, in this case, we just looked at the Foursquare check-in data, how well does that perform in identifying the correct check-in location of an individual? Well, it turns out, depending on which K you use, which is how many points of interest you provide, across our data set on average, we can actually de-anonymize your data set by about 30%. Right? So just by knowing the time of day that somebody goes to a place, we can reduce the anonymity of what they think they're reporting by 31%, in some cases 38%, depending on the point. Well, that's great for sort of just understanding points of interest in a sort of single approach to time. But what about all those other patterns that we had? Are they all created equal, or do they all have different sort of variance in terms of what they're able to report? So we have our Foursquare, we have our Google, we have our hours of operation, we have our places, this is our popularity here. And then we can just compare those to see which one of these performs best in identifying or predicting the location of somebody in a K-anonymized data set. What we can see in a lot of cases is popularity, which is our atemporal pattern, doesn't care about time, it purely cares about how popular a place is, actually performed the best, which is kind of interesting to us. Right? So regardless of the time of day, if you purely ranked your places based on which place was most popular, maybe not surprising, more often than the rest of the data sets we had, was able to predict the location you had. So like 80% decrease in anonymity purely based on the popularity of the place. So the next logical question then is, well, what happens if we combine all these, right? Data scientists, we don't like to take individual data sets. We want to always merge them together and see what we can do. So what if we take a weighted combination of all of these different approaches? And then the question is also, do all of them matter? Or is there correlation such that we need to remove one and just keep a subset of them? Well, it turns out if we combine them, and I'll talk about the weighting in a second, we drastically improve our ability to de-anonymize someone in the data set. So in some cases, by 172%, almost 200%, we can reduce the anonymity of somebody in the data set by just taking these place level, publicly available points of interest, temporal data sets and our popularity, to then sort of determine where somebody's likely to be at. So our K-anonymized approach doesn't work so well if we know the places that somebody is potentially going to. Our approach for actually doing this, and there's a lot more in the paper, I won't get into the sort of details of this, but if you look at the weighting we actually came up with, which is our optimal weight, we tried a wide range of possible weightings that we could apply to this. It turns out that the most important one, our place popularity, which is our atemporal one, it's important to have, but the amount that you actually have in doesn't make a big difference. What does make a difference is the nuance that you introduce with the temporal patterns. So popularity as a baseline is going to do really, really well, but you can slightly improve it by including all of these additional factors, and each of them contributes something to the nuance in the actual prediction that we actually have in this case, which we thought was quite interesting. So from this this work, sort of the trying to de-anonymize data sets and work in that domain. The other sort of flip side of this has been, well, now that we sort of know what people can do with our data, how do we preserve the privacy of this data? Right? How do we take this data and say, as an individual, I want you to have access to your data and use your data in a useful way and share your data with people. But I understand there's a lot of concerns and there's not a lot of options out there for sharing information. So like I like to share my location with my partner if I go for a run or something, or if I want to meet up with some friends, I can share my location. Typically that's done through something like Google Maps, right? Google Maps is location sharing, or you can check in a social media application and share that with your colleague. But a tool that we developed, and we'd love some feedback on it, is Privy2, which is a web-based application and a mobile application that you can access and download for right now. The purpose of Privy2 is to offer a sort of obfuscated and secure way of sharing your private location with individuals. And what it does also is it realizes that the relationships between people are all unique. And so many of the approaches that you have right now are a single approach for everybody, right? So I can share my exact location with you. I can share my exact location with my parents. I can share my exact location with my friends. But the relationships we have are different, right? I might actually want to share the city that I'm at with you, with, I don't know, my parents, for instance, and I want to share the exact geographic location that I'm at with my kids. So this sort of approach that we're taking of, location is the same for everybody is a fallacy, I think, and we need to have more sort of dynamic approaches to handling this. So we can take different geometries, or different geographies in this case, and choose who gets access to what level or resolution of information about me. And the way it works in our approach anyways, was that we obfuscate these locations using different geomasking techniques, and then each individual gets a key. And that key, depending on what key you have, unlocks a different resolution of information, different resolution of your location. So if I give a key to my parents and I give a key to my kids, they can unlock either my exact location or a broad area that I'm in, depending on which key that I choose to give them. The idea is that this is a hashed or encrypted location that I can share anywhere, and anybody that has a key at any time can unlock this. This is all encrypted through the device, and the only information that's actually stored on the server is the encrypted location information that you have. So this has been kind of our approach to handle or offer something back to the community that we're actually taking so much data from, right? And building interesting models, or trying to understand human behavior, trying to understand placial behavior by using user-generated data, and realizing that there should be tools out there to preserve the privacy of the location information that we're using. So to summarize, as I'm just coming out of time here, very broadly to summarize the kind of things that I talked about today, space is only a single dimension in what we call the complex, multi-dimensional concept of place. And depending on sort of how you define this, we all work with different dimensions of geography in this case. We just encompass it under this term place, and have been approaching it from this placial concept or placial methodology that we've been talking about. I think mobility is essential to understanding place, and some of our ongoing work is to try to sort of bring these together when we talk about place and movement between places. How do we better understand? These are all sort of pieces of the pie that we need to get in order to get a more holistic understanding of regions, of urban space, of places that we visit. And then when we talk about placial information, we understand that a lot of this exposes a lot of private information. Right? This is something that I think a lot of organizations, companies, and some government bodies understand and realize, but I think it's something that a lot of the public does not understand or realize, and arguably care about, right? And so I think part of our job as academics, as researchers that use these data, is to discuss the privacy implications of these data, especially with newer generations of students that are probably much more tech savvy than me, but may not be thinking critically about the issues with the data. I'll leave it there. This is my lab group. Obviously, none of this is possible without some phenomenal students that are taking the lead on a lot of these projects, and so I want to thank them here as well. And thank you very much for listening.
Yes, so thank you so much, Grant, for fascinating talk and different sections of it were all such that I guess that we could be concentrating on discussing of each of those even. But questions in the audience for Grant, comments? Maybe you can introduce yourself if you like when you start.
Andrei Karasov, postdoc in lab, and first of all, it was my pleasure to listen to such a fascinating talk, beautiful visualization and analytics. I have two questions. One is more theoretical. So your conceptualization of place and space was thought-provoking, and I thought, so we have these physical dimensions of place, we have some social aspects of which adding complexity to place, like sense of place, identity, some experience, etc. While maybe from point of view of geography, would this be some particular organization of whatever dimension of environment creates a place as a metaphor of reducing the environment in our mind, and another kind of organization might produce landscape, for example, also in our mind. So there is no specific difference type of organization. This is first question, and another about Tableau. So I see that such a mix map is a very customized tool with maybe Tableau technologies under the hood. So is it produced under some kind of academic license or completely custom internal thing which you developed?
Sure. Yeah. Okay. I'll tackle the first one first. Yeah. I mean, I think an organizational sort of approach to sort of the semantics or understanding place is, at least how I defined it, is absolutely a sort of a reasonable way of sort of envisioning this or viewing this. I think it all comes down to sort of this shared understanding of place, right? And so much about what I've talked about here is basically saying this is how we are conceptualizing space and understanding it. And we're going to group everybody into the same bucket here and approach it in some way. That's obviously not the way the world works. We each have individual perspectives and understanding of this, and part of our culture is that we categorize or cluster or organize in various different ways. And so if you're somebody that's from a sort of maybe landscape architecture or ecology background, and your understanding of place is going to be very different from the understanding of place that we're talking about here with like mobility patterns and some of these other things as well. I think they're all lenses, I guess, is my answer to this. And so depending on what set of glasses you put on, you're going to have a different view about what that looks like. I think that the interesting part about that is that what we're looking at hasn't changed. It's the glasses that we're putting on that's had a different effect on it. So it's still how we interpret it, how we choose what data sets we have access to view that environment and do the analytics on. But it's going to vary depending on how we approach that. The hope is that we all sort of see similar things. We just take a different approach or different way of analyzing a different understanding of that world. But I don't. There's no sort of clear answer, I think, from this side. Each group or even different organizations is going to approach this differently. I'm not sure if that answers that question, but I'll leave that. I'll go to the second question, which is Tableau. So that tool actually, we developed it, it was a visiting researcher with Tableau Research. So Tableau has a research division, which is a bunch of PhDs that do research in this area. They actually don't use Tableau tools that often. Most of what they do are customized tools. Most of them are HCI, human-computer interaction PhDs that are more interested in sort of assessing the visual cues and analytics and sort of interaction with computer systems to help improve the Tableau platform and software. And so this tool actually itself was entirely built off of Leaflet, D3, just open JavaScript technologies. I guess Postgres backend and uses Python as the handler for it. And so yeah, we have a publication out there, and I think the source code is online. I would hope that it is, but it gets kind of weird with Tableau and some of that stuff too. So if it isn't, then you're welcome to email me. I'm happy to share source code with that.
Further questions?
Yeah, hi. Elias from DGL as well, and thank you for the really interesting presentation. I was wondering, at the end you said that you're now planning to connect these two research lines of places and mobility, but there also you mentioned that looking at the visits. But I was thinking that, have you done research, or are you planning to look at these in-between places that people don't visit, but they actually travel past? But that might be very interesting, especially from the micromobility, walking, cycling perspectives, and to compare different areas, like which are the types of places people travel past in different areas.
Yeah, it's a great question, and I do have an answer for that. We have been looking at that actually. My PhD student Priyanka is interested in that. What she's referring to is what traversal places, right? So if you look at origins and destinations for trips, the places that people will go through to get to wherever they're going, right? And so basically, if you compare what regions people stop in or start in compared to regions that have a low distribution of that, and then also comparing that with our certain diversity discussion, right? So with issues of lower income communities, areas where you don't have like high populations, more industrial areas as well. And I don't have any results to report on that, but I would hypothesize that a lot of the areas that people are going through tend to be poor communities, tend to be communities that don't have a lot of access to things. It brings up discussions about food deserts or other components, so there's not access to certain things you might need in those areas. But it is an area that we're doing work in that sense.
Hi, Sarah, visiting postdoc at Halsos. I was wondering your results, did you communicate them to urban policymakers or planners, and how did they react, or or if there's any research from that side of planning?
Yeah, so the various different projects, some we have communicated with, like some of the mobility stuff. We worked with the city in DDOT in Washington, D.C., reported some of that back to them. And then in Montreal, we've done some work with the city of Montreal, talking about how e-scooter users have sort of the patterns of e-scooter usage and behaviors. Specifically with those, there's a lot of, that's really interesting. Thanks for sharing that. We'll put that over here and not look at it ever again, kind of thing. I was part of the pilot project for e-scooters that happened in Montreal, and so they basically asked for my recommendation on what should happen, and this was very early on when the e-scooters moved into Montreal. And not surprisingly, people left scooters everywhere. You were supposed to wear a helmet in Montreal. Nobody wore a helmet. Stuff that we could all easily predict was going to happen, and that was essentially used as an excuse to cancel the project. My suggestion was not to cancel it, but have a better sort of approach to handling this sort of stuff. So yeah, it's met with sort of some good reactions. Sort of people are interested in seeing this, and others are sort of like, there's a political part of this that just doesn't really care so much. The other stuff we talked about, like some of the mobility, some of the activity patterns sort of before and after, or before and during COVID, that's something we published. I sent it out to a colleague of mine who's at the Government of Canada just to talk about, isn't this interesting? I wonder if we could do a similar study with maybe some other Statistics Canada data we have. And again, it's kind of, some of this sort of falls on deaf ears in some cases. It does, unfortunately, in some cases, especially in certain parts of the world, you do feel like you're screaming into the void a little bit as an academic, but I think it's important to keep screaming, and eventually somebody will listen. So yeah. Hopefully that answers that.
Hi, Chris. I'm also postdoc in Digital Geography Lab. I want to take the same question to the privacy side and to these platform actors, this giant platform economy, data economy. All the big actors in that field, really, they want to have the data, and they don't want to carry out any pseudonymization or anonymization measures in the end. Now we've been having here in the European Union for more than 5 years the General Data Privacy Regulation, so GDPR, which have quite strict rules of what you can do with what data and what intents you have. But what's happening is that a new field of engineering has come up, and it's even called engineering, so privacy engineering, fitting exactly, like fulfilling the letter of the law and nothing more. Do you have a feeling, or do you have maybe a comment on how the collaboration with these companies work, and can you as an academic influence them to maybe not only consider the business?
Yeah, it's a good question, and I don't. To be honest, I haven't discussed much of this with a lot of companies. Like I have colleagues that this sort of discussions come up over a coffee or a beer sort of thing. But so like you mentioned, so much of this is like the discussion about privacy is a marketing discussion, right? That's all privacy is, and when we talk about preserving privacy, there's really no interest in taking any action, as you pointed out, or the action that's taken is in an attempt to sort of to get by a lot of the privacy regulations or meet them to the letter of the law. There's some actions that have been taken which have been really interesting, like the differential privacy is pretty prevalent in a lot of these companies now. And the main reason behind that is because they're not using, like they still have all of your data, but when they share your data, they're sharing differentially private versions. So they're sharing attributes that don't identify individuals. And in some ways we can be thankful for that because there's been some acknowledgement that we need to, preserve the data when we share it so that we're not sharing, information that's exposing individuals. But that kind of defeats the purpose internally because they still have all this data they can do a ton of analysis on, and through various sort of legal means they can share the data with governments if they need to, right? So Apple share data with China based on just a requirement that China asked for this kind of data. My discussions haven't been very fruitful in that domain, and I haven't seen a lot of sort of change in this. I mean, the work that I talked about with the Privy to, it's a cool research project. It's really interesting from a design perspective and from a geospatial theoretical discussion. The number of people that will adopt that is probably quite low, right? You'll check it out and say, this is kind of interesting. It's kind of neat to share your location, but Google makes it so much easier. We're all using Google every day. We're all using whatever service. The means to adopt it, I don't have the ability to hire the sort of cognitive engineers to force you to use my application that a lot of other apps. Yeah, that's my answer. Yeah. I mean, I don't want to be too negative with it. I think so much of what we're responsible for as academics is doing some of the work that is not the sexy work in some cases, right? Is not the work that is going to, just collect more data like the companies are doing. Part of our job is to sort of expose what is possible with some of these data. And while that is a negative side of it, it doesn't bring a lot of positivity to it, I still think it's an important discussion to have. So.
I could maybe continue by raising two questions that came up in the online chat. So one is about the data behind the micromobility travel times, and the question is, does TIER have, like TIER, I guess, provider, have or provide some kind of data on the ridership via their API or otherwise? And the question is about like demographics, like age or gender.
The short answer to that is no. And the longer answer to that is that a lot of these companies, including TIER, are required to publish like a JSON API of where vehicles are available. They use the micromobility data services specification or the GBTFS or whatever specification to do that. And so a lot of cities mandate that they publish these to operate in a city so that theoretically somebody can go and find a scooter or e-bike whenever they want to, including a city official that sees it knocked over on the side of the road. But what all those APIs do is they basically list the latitude and longitude of a vehicle anytime you request from the API. So right now, where are all the available vehicles in Helsinki? So what we've done with that is we basically took snapshots of that data every minute, and when a vehicle disappeared, we considered that the start of a trip, and when a vehicle reappeared, we considered that the end of the trip. But that's the only data we have, right? So we just have GIS level data, latitude and longitude, an ID for a vehicle, and then basically the duration of how long that vehicle took. We don't have any socio-demographic data or any kind of biographical demographic data, which would be great. That's something that the companies are collecting. There's a lot of surveys that go around, like Lime, for instance, collects a lot of that information, and there's a lot of efforts right now from governments to ask these services to be more aware of lower income communities, so offer subsidies, offer like free rides to people that couldn't have some mixed opinions about how useful or valuable us as researchers getting access to demographic data would be great. They just want to hold on to a lot of that. Yeah.
Okay, and maybe one more question from the Zoom chat, which is about criticism towards the research. So how would you respond to the critics that say that using user-generated data without informed consent is predatory, and that us as researchers using these data only support the state surveillance? So what is the best argument for this criticism beyond listing the ways of processing and displaying the data in a privacy-preserving way?
It's a argument that we face all the time, and it's a reasonable argument. It's a very valid argument for what we do is using these data and collecting them without asking for consent. The first part is we have a very difficult time asking for consent for any of this user data because this data is published and public online. I think part of our job here is to inform people of how this data is being used, right? So if people are sharing data publicly, the argument has always been, you're choosing to share this, it's out there, we can use the data for whatever analysis we want. Whether you agree with that or not is a whole separate discussion. I do think it sort of behooves us to then sort of make it clear what we can actually do with this data as researchers. I mean, theoretically, we're supposed to be the ones doing no evil in a lot of cases because we're responsible to the public. A lot of the research we do is taxpayer funded. We talk about some of the patterns we find. We talk about how these data are being used. We're using that in a different way than a lot of major companies and corporations that are siloing this data and not sharing these kind of results. So I think there is a responsibility to us to talk about this. I think from an informed consent perspective, I don't have an answer to that. I don't know how we would do that. I don't know if anybody has a sort of a solid idea of the best practices for that. In some cases, like my university, it's a bit of a gray area whether you ask for ethics approval in using some of this data, but for some of the data collection that we've done here, we have got ethics approval from the university. It goes through an REB board for discussion. In other cases, it hasn't. But that's a body of my colleagues that are determining whether that's useful or not. The same discussion is happening. That's not really informed consent. That's just review of how we use the data. That's sort of my long-winded answer to say I don't really know. I think it just is up to researchers to talk about this continually, to make it clear what can be done with the data so that people, when they choose to share the data, know what can happen.
Right, thank you.
One reflection to follow up on that thought is a question that I had about the active and passive sensing of data sources, and then I thought that where does the sort of border actually go? That how much there is actually gray area in between. So active sensing is like unclear, I guess. So how we've approached it is often so that active sensing is like in terms of, for example, urban planning. We've thought that active is something which is like public participatory GIS, so when the people really know where they contribute their data to. So whether it's only the activity of sort of actively posting an Instagram post, for example, or whether it's actively knowing where the data lands ultimately. And have you been thinking about this sort of active, passive, and or is there something in between that we should be recognizing from the perspective of the consent, which nobody sort of really reads?
Yeah, I guess how long do you have? We could. It's a good question, though. I mean, this is clearly overly simplified. There's two slides. One's passive, active, and I think it's probably too simplified in that case to discuss that. But just giving examples, yeah, I spent a lot of time thinking about this and discussing these sorts of things, and increasingly thinking about it from a geography perspective too. So we, historically in geography and public participatory GIS, we talk about like VGI, like volunteer geographic information. And some of the discussions and work that I've had over the years have been like, well, what is actually volunteered in some cases too? It fits into the same discussion. Am I volunteering geographic information, or am I volunteering information that has geographic content? And I think there's a distinction there, in that like VGI, we often think of a good example is like OpenStreetMap, right? You're contributing geographic data to a system with the knowledge that it'll be used by third parties for some benefit. But if we think about something like Instagram, right? Check into I tag a post with a location, but the purpose of the Instagram post is not the geographic content. The purpose is the photo that I'm sharing with my friends. And the geographic content is just something I'm using because I think it's fun, it's really interesting, but turns out a researcher over here finds that incredibly valuable to understand what I'm doing and where I'm going. And so I kind of made this argument that that's coerced geographic information, right? So it's information that Instagram has convinced you that you need to post this photo to have some social relevance and social saliency, and has coerced you into contributing more information than you maybe would normally do because there's some value to what they get. Geographic locations, they can use that to understand movement behavior, and we can use that as researchers to better understand. So the question then is that is active contribution, and I would say, in somebody choosing to upload a photo, but the geographic content is sort of this weird area whether you're sharing that with the purpose of that being used. Is that active, or are you sharing it with a separate purpose? Like, what is the purpose of the data contribution in the first place? So we could have a whole other discussion about what that means, but you're absolutely right. There's a massive gray area in how people contribute the data. It's not just passive or active.
Hi, Tuomas. Still a doctoral researcher at DGL, so until Friday at least. So yeah. So thank you for the really good presentation. And I have a question kind of relating to these past two questions and the location privacy. So geographical and temporal contextual information are really important to kind of identify, like in your example, like, okay, from which of these example points of interest would be the most probable location of the individual. Have you considered then like these trajectories or the timelines of the individuals? So if, for instance, if they have previously, just like let's say 30 minutes ago, checked in at their place of work, and then it's a Friday evening, and then they're checking in somewhere else, and it might be, especially if, I don't know, in Finland or the UK, it might be a pub, like a Friday beer. So have you considered this kind of previous or the kind of historical contextual information also in this anonymization process, because that can be even more kind of influential on identifying that location?
Yeah, the short answer is that that's something we thought about. We haven't implemented it in this case. I mean, the model that we're presenting here is a generalized model, right? So it's meant to sort of just approximate what the average sort of typical patterns people would exhibit. But the next logical step in this is the personalized approach to that, right? So if you have a trajectory or a history of check-ins or a history of where somebody's gone before, clearly you can do some sort of like Markov chain approach or something where you could estimate the next likelihood place and merge that with this to sort of boost certain regions or certain others. We did some work early on where we were looking at the diagnosticity of where people go. So if you have a sort of daily pattern, sort of a travel diary based on check-ins, people going A, B, C, D, if you have that for a whole bunch of people, you can kind of see some similarities, right? Jane wakes up in the morning, goes to the coffee shop, goes to work, goes to the grocery store, goes home. Joe does the same sort of pattern. But occasionally there's like a Mary that goes skydiving, right? Like in the middle of that. And so you're looking at these patterns and you're like, okay, there's predictable behavior for most people. But that's, if I'm building a recommendation system or recommendation engine, I'm going to recommend or identify Starbucks because the vast majority of people go to Starbucks Tuesday mornings at 9 a.m. But what I'm most interested in is Jane, right? Because I want to know why Jane went skydiving on Thursday afternoon, because that's the actual value add. The habitual behavior doesn't really mean much to me. It's the uniqueness of the diagnosticity, I think, what some of the patterns that were reported in this case. And so when you're building a model for privacy prediction, it's very easy to just assume everybody acts the same. But if you want to really preserve privacy, you need to know those outliers, because that's the person that's exposing the most amount of privacy, because they're the most unique in that case. So we need to sort of have better models to approach that. And I think, like you're saying, individualized models is a way to handle that.
I have one question. Thank you for your interesting presentation, Kamyar. I'm a lecturer in geoinformatics here. You talked about data anonymization, and we earlier also talked that anonymization is basically, we have a trade-off between how the utility and how we can protect privacy of individuals. You talked about the privacy side and how, for example, linking data with other data sets can compromise the anonymity. My question is, have you looked at the other side of this trade-off? Have you looked at how usable data is after, for example, applying displacement or geomasking or whatever method you use for anonymization?
Yeah, it's a good question. Let me see if I have it. Might have a slide about it somewhere in here. They're all my extra slides that I have. This one. So sort of some of our privacy work that I didn't really talk about here was then taking those points of interest that have been anonymized, like basically if you have a region that you've generated based on a either convex hull or circle or bounding box for a set of k anonymized points. So you have 5 k anonymized points. As geographers, we love to report regions. For some reason, we're obsessed with polygons, right? We like to report these things as a likelihood place somebody's at. If you have our sort of k-anonymized approach, which is to basically say, I need to expand the number of points that I'm reporting in order to preserve the same degree of privacy that I had before, this is basically measuring that utility loss. So how big do I have to make that region in order for it to still preserve the privacy, and how much utility am I losing from between the actual k-anonymized model and what we refer to here as our placial k-anonymized model, which actually considers all that other identifiable information that we have. And so part of this is basically measuring over our 20,000 check-ins what the average growth in area is, and that in some sense is our proxy for utility. So how much utility do we lose by improving privacy by n or x in some cases? So we have looked at that a little bit. I think we still need a lot more discussion about that, and things like k-anonymity are entirely dependent on the user. So what they specify as k, how many points of interest they're comfortable with reporting, that's up to the user and what they want to do. And so that's kind of our way of sort of wringing our hands and saying it's up to you, like we shake it out, you deal with that. But I think we need to be able to report, and what we do in this paper is, depending on what level of K you pick and how much information you have access to, what is a reasonable amount of utility that you lose in sharing this kind of information.
Questions from the audience?
Hi, Robert from Digital Geography Lab, a PhD researcher. And my question is about the platform that can be used to compare micromobility across different cities. I don't have the name available right now. But could you go into what exactly is the data that it's observing? So is it like from a certain amount of e-scooter providers, for example, Lime, Bolt, and X, Y, Z, for all the cities, or is there like locally specific information available as well, such as, for example, the local implemented bike sharing systems?
So the data that we have for the comparison is entirely based, in each city it's actually one provider. So in some cases it's Tier, in some cases it's Bolt, some cases it's Lime. In most cases we have a lot of the Tier data for a lot of European cities. In the US we have data from Lime. And so yeah, it's just one e-scooter or e-bike. So most of them have e-scooters and e-bikes in their system. And that's part of what we're building in the tool, is your ability to select which mode you want, e-bikes or e-scooters. But yeah, it's entirely based on those systems. There's no local information that's being included.
All right, thank you.
Yes. Hello. Olle from Digital Geography Lab. Thanks for the presentation. At the beginning, you described how temporal variations took place before and after COVID, and you compared the cities. So I'm wondering, did you do some more detailed analysis regarding, for example, checking city centers, what happened there, or the urban structure in general within city? Did you had any look or?
So, the short answer to that is no. Like for the work that I talked about here, we were really just sort of interested in, like we took census tracts in each of the cities, and that's where we got our socioeconomic and demographic information from, and then matched that to places in those areas to calculate the change in visitation time for them. But we didn't actually compare within the cities from that. We just took those as numbers and then looked across cities. Some of the work that another student of mine has been looking into right now is sort of regional, like within cities, what those, not the duration is, but the temporal patterns, like what times of day people do certain things. And we've done some work in the past where we compared that across cities, but never within cities. And so that he's trying to look at that a little bit right now, but it's still very early on some of the difficulties with that too is there's a big sort of sparsity issue, right? So you can get, depending on how big you make your regions or how small, you get a lot of variety, like variance and standard deviations that happen in those reported values that lead to some insignificant or non-significant results. But yeah, we'll see what that looks like as he continues to delve into it.
Yeah, thanks.
I don't see any hands up at the moment, but I do have many questions in mind, but I also am aware of the time. So I guess we should be closing, and we'll continue discussing still here. If somebody wants to be staying for a while, we can continue discussing on the corridor. So, but like officially for the online participants and official participants, students and so forth, we could be closing the session by giving a big hand to Grant for his presentation once more.